Okay, guys, very quick. We was doing a 15. We have to do 15.9 about the triple integration in a sphere coordinate. See, this one is a graph, and the graph you have three components, so you have to know which is the rho and phi and theta. And remember, the rho is the distance between the origin. Let me write it down here, between the point and the origin, from the origin to the point. That distance is called rho. Okay, is here. Now, the z-axis, the z-axis to the position, the angle is called phi. Is this one. Again, the z-axis to the origin, no, to the position is called phi. The angle is called phi. Okay. Same thing apply for theta. You know theta already is a projection orthogonal to the x-axis, to the xy plane, and then you take the position from z-axis to the position, to the projection of the position of xy plane. Okay. So the definition is right here. The definition of the sphere coordinate of a point P in sphere in space of phi and theta and phi, rho, theta, and phi, where theta is a distance from the origin to P, and P is the point, the point I was telling you, okay? Okay, and P is the same as the cylinder coordinate. That's a theta. So the phi is the angle between the position z-axis and the line segment OP. And remember also, phi is always positive. Rho is always positive, and phi is between 0 to pi. The coordinate on, you have two type of coordinate. Let's check the relationships between the Cartesian coordinate and sphere coordinate. The Cartesian coordinate is xyz. So the sphere coordinate is rho, phi, and theta. Rho, phi, and theta. This is called sphere coordinate. If you have x, y, z, this is called rectangular coordinate or Cartesian coordinate. Got it? And the relationship is right here. X, y, z, the relationship between the rho, phi, and theta. And x squared plus y squared plus z squared is equal to phi squared. Okay, just let me give you one example. So example, so if I ask you the point, just for example, the point from, you can also check it on the book, the point pi divided by 4 and pi divided by over 3 is given in spherical coordinate. Okay. Question. Plot the point and found its rectangular or Cartesian coordinate, but it doesn't matter. It's the same. Coordinate. Okay, you have this. So this one is given. Remember the first one, if you have a 2 pi over 4 and pi over 3, this is nothing than rho, theta, and phi. And remember the rho is here is 2. Theta is pi over 4. And phi is pi over 3. Okay, that's phi. Okay. So you have the position here. The position is easy to draw here. That's x, that's y, that's the z. So just think about, you have a circle here, and the pi over 3 will be like this here, the position of P. That's the pi over 3. pi over 3 is exactly here. That's pi over 3. Okay? That's the phi, which is just pi over 3. Okay. That's the point, by the way. The point is 2 pi over 4 and pi over 3. And just make sure if you project here on the x-axis, you can have here the angle here is pi over 4. That's the projection. And make sure the distance between here to here, the distance between the origin to P, it's just 2 because you have 2 here. Okay? It's 2. Okay. That's how you can plot. Okay, now let's find the rectangular coordinate. And remember the rectangular coordinate, you have x is equal to rho sine of phi and cosine of theta. And this one is nothing than 2 times sine of, remember this phi is pi over 3. And you have cosine pi over 4. And you have, and remember if you have a unit circle, pi over 3 is here. And they ask you to find the sine. The sine will be then square root of 3 over 2. And the cosine will be, the cosine pi over 4 is just a square root of 2 divided by 2. And you can see here the 2 will cancel out. So you have a square root of 6 divided by 2. That's the x. X is equal to square root of 6 divided by 2. Okay, you got one of them now. Let's find the y now. So the y-axis, the y is equal to rho sine of phi and sine of theta. Okay? That's the formula. So you will have 2 times sine of pi over, what's the phi? The phi is sine over 3 and sine over 2 pi over 4. And this is not the same thing because sine over 4 is equal to sine of pi over 4 is equal to cosine pi over 4. It's the same thing. So you will have 2 times square root of 3 over 2 and square root of 2 over 2. 2 cancel out. So you'll have just the same thing. Y is equal to square root of 6 divided by 2. Then for x is equal to y, you can tell easily. So let's find now the z. The z is equal to rho times cosine of phi. And rho is what? Rho is 2 times cosine of phi. And phi is, go back. What's the phi? Phi is pi over 3. Is pi over 3. And remember, cosine pi over 3 is just 1/2. So you will have 2 times 1/2. And which is just 1. So then z is equal to 1. Then your the point, then the point. So because they give you that point, the point 2 pi over 4 and pi over 3 is spheric coordinate. That's the point. It's spheric coordinate. So the spheric coordinate, like the rectangular coordinate, is square root of 6 divided by 2, square root of 6 divided by 2 and 1 in rectangular, or you can call it also rectangular coordinate. That's the way you do it. Or you can just say the rectangular coordinate is this one. That's it. The rectangular coordinate is just this one. Square root of 6 divided by 2, square root of 6 divided by 2 and 1. Okay? Good. That's it. And now let me charge it. Now let me just move on to the next one, which is okay. Good. Okay, let me move on to the next example. So that's the way you do it. It's on your textbook, the exercise. You can go check it out. But I advise you now to start doing the homework on the review packet. Not the homework, but the review packet. Okay, for your final exam. So another example. So now they give you a point and they ask you to find the spherical coordinate. So another example, if you have, if they give you a point, the point 0, 2 square root of 3, negative 2 is given in rectangular coordinate. Okay, now the question is to found the spherical coordinate for this point. Okay, so this one is given, and remember the 0 and 2 square root of 3 and negative 2 is equal to x, y, and z. And remember in the spheric coordinate, so you have x squared plus y squared is plus z squared is equal to rho square. Okay, so since this one is given, it's just 0 squared plus 2 square root of 3 everything square plus negative 2 everything square. So what you have is just 0 plus 4 times 3 plus 4. So this one is 12 and 16. It's just 16. So rho squared is equal to 16. So what does it mean? Rho is equal to positive negative square root of 16, which is positive negative 4. But since, just like I told you here, go back. What did I tell you about the rho? Rho is always positive. So that means you only have to pick 4. So then for rho, since rho is positive, then rho is equal to 4. So then you can tell easily rho have to be between 0 to 4. The maximum the rho can reach here in the example is 4. So you have rho is equal to 4. Now let's try to find the theta and phi. Okay. So let's start with x first, or rho first. So let's start with the z. So we try to find the z. Since we have the rho is equal to 4, let me circle it. So you have the rho is equal to 4, and you know rho is equal to, z is equal to, let's find the z first, since z is given. Z is equal to rho cosine of phi. Okay. Z is given, rho is given. What's the z? Z is negative 2 is here. This is z, and rho is always given, is already given. Then let's find the phi. So this one is just negative 2 is equal to 4 cosine of phi. What does it mean? Will imply cosine of phi is equal to negative 1/2. Why 1/2? Because negative 2 divided by 4 is just 1/2. So you have this one. So this one is nothing than phi is equal to, okay, here you can just choose 1 point. That's okay. Okay, you can choose 1 point. So you can just choose phi is equal to 2 pi divided by, because it's 1/2. If you look at here, you have cosine is equal to 1/2. Okay, and you have the cosine is equal to negative 1/2. Then the phi have to be 2 pi over 3. Okay, it's 2 pi over 3. That's the phi. Okay. You can also use the k. I just use a specific k when k is equal to 0. Okay, you can use it. You can write down as 2k plus 2k plus pi. Okay, plus 2k pi, and here is k is equal to 0. So you have 2 pi 3. So the phi is equal to pi 3. So now let's find the x. The x is equal to rho sine of phi cosine of theta. So now let's find the theta. So this is nothing then. X is 0. So 0 is equal to phi. Phi is 4. Let's just replace it. 4 times sine of 2 pi divided by 3 cosine of theta. I want to find theta now. Okay. 0 is equal to 4 times sine of 2 pi. The sine will be then, let me check here, if you have this one. Okay, and you have cosine is pi over 3. Look at here, pi over 3 is right here. So pi over 3 plus, let's plus pi. What you have is 4 divided by 3, pi over 2. So what you have is 3 and 2 is 5. You can still have 3 and pi here. You can have pi plus pi. You have 3, 4, and you have 2. You can subtract also by this one, pi. So you can have pi, okay? Look at here. You can take a pi, subtract by pi over 3, and then you can have 2 pi over 3. This is the best one, okay? How can you have a pi over 3? You know pi over 3 already. Take the negative pi over 3, and then add pi, you can have a 2 pi over 3. That's the faster one. So you can have this one, and then you can end up having sine pi over 3, and which is just 0. And you can end up having 0. Okay, this one is just 0, because everything here is 0. And this one is non-zero, by the way. This one, the sine of 2 pi divided by 3 is non-zero. And then for sine of cosine, you don't have to know the number, but cosine of phi is equal to 0. So what does it mean? You can have theta is equal to pi over 2. Okay. You have this one, and you have this one, and you have the row. Okay. So now you're done. Now you have the spherical coordinate. The spherical coordinate is just rho first. That's the question they ask us. Okay, it's rho and 2 pi divided by 3 and pi over 2. Okay, you have the row is 4. Write down 4, and the next one is theta, and theta is pi over 2, and the last one is 2 pi over 3. That's it. Okay, now let's find the triple integration in spherical coordinate. It's the same process applied by using the Riemann sum. Okay, by using the Riemann sum. Remember the Riemann sum we did on calculus 2, by using the green points, and you take the limit. Without taking the limit, if you take the summation, that's approximation of the area. Same thing apply with the volume. For the double integration, you have to take the two summation. This is approximation of the area, not the volume. It doesn't mean it's the exact volume. It's close to the right. But to get it the right volume, you have to take the limit. Okay, you have to take the limit and think about the number of the subdivision. If the number of subdivision is going to infinity, and then you will get the right limit. Okay, this is the same thing apply. I say it in class many times. Same thing apply here. Okay, so for the spherical coordinate, you can check your textbook. You can check your textbook. You can have a box as your. You can have the box as your. Let me draw this one first. You can have the box as your. Yeah, you can have the box as your cross section. Okay, take one box outside as your cross section. So, and from the origin, you can match them, and you can see which angle go to, and you can find the theta and the change of the phi. It will look like this. Okay. So just check the textbook for the graph. I'm not good on a graph, but know that if they ask you to find the volume, on the region E in the space of rho, theta, and phi, such that rho is between 8 and B, and theta is between alpha and beta, and phi is between C and D, for example, just for example. Okay. Now, by Riemann sum, same thing applied. The volume of each cross section. The volume of each cross section is what? If you have a box, it's the length times weight times the height. Told you many times. Any box is like that. So if you look at here, you have the volume of that cross section is equal to, remember, it's in 3 dimensions. It's I, J, K. Same thing apply for the cylinder. It's equal to rho I squared, because you will have a variation. I will explain to you later on where the rho square come from. And you have the sign of phi k and d, which is the change of the rho and the change of the theta and the change of the phi. Now, let me go back. The weight. If you have a box, my box, the way I draw the box is a little bit, it's not nice, but just understand. Okay, look at here. So the distance between here to here is just rho I sine of theta k d theta. It's a rate of change of the theta, okay? And that distance is just a rho I d phi. So if you multiply them, you have rho square I and sine phi k. It's where it's come from, okay? Now, to approximate the volume, you already know I don't have to do that. But to find the volume of the cylinder is equal to proper integration in the region of E of fx, y, z of dv. Now, since we divide the cylinder in M, L cross section, okay? We divide the length, the height, and the weight in MNL cross section. On that way, so if you want to approximate, you just use the Riemann sum by doing the 3 times the summation. And then if you take the limit now, you can find the volume of the cylinder. And make sure those cross section, each side will go to infinity. And it's just the limit. You have to take the limit of L, M, N, and you have to know the definition of those, where these come from. I told you, these come from, you divide it on the right side, left side, and the height in N subdivision. This is L subdivision. This is M subdivision. This is N subdivision. each site you have to divide it in a different separate subdivision. And then for if they go, because let me tell you some things about the difference between the right volume and the Riemann sum. The Riemann sum is approximation. You won't get, you will always have error. You can have a space between them. That's error. That's not the right one. But if LML go to infinity, it will be tight. You won't have no space between them. That's the real volume you want to find. You got it now? Good. Okay, this is a sum. You take the the triple sum of you can call it here I going from 1 to M or to L, for example, since we start to L, and you can say J is going from 1 to M and K is going from 1 to N. And then you can use the F and make sure you choose any points. That points is called any points. That point is called most of the time they name it star, X star, Y star, Z star. And just make sure if it's three-dimensional, you have to say X star I J K. Always Y star I J K. Z star I J K. If you miss the I J K, it's wrong. So when you deal with Riemann sum, you have to put always I J K. So you have X I J K star, and then Y I J K star, and then Z I J K star of dV. And remember, the dV is nothing than this one. That's the volume. You can take this one, replace here, that's fine. This one is called triple integration. And now you're good to go to do some exercise about the triple integration, okay? You should be ready to do, let me just give you one example. I don't have to do it, but just let me give you one example, okay? So one great example is if they ask you to evaluate, for example, if they ask you to evaluate the example, evaluate. If they ask you to evaluate the triple integration of the region B of EX squared plus Y squared plus Z squared, and you have everything 3/2 in dV. And you have the B, which is the region of X, Y, Z, such that X squared plus Y squared plus Z squared is less equal to 1. Okay. You have to change it to spherical coordinate. So then the B in the space of rho, theta, and phi will become, the rho, this one is nothing than the rho. Here, bear with me, this one, here. This one is nothing than rho. Then for the rho is less or equal to 1. And the rho is positive, then it's positive here. You got it? And also the theta is always between 0 to 2 pi. This is done. And then phi is between pi to 0. That's it. And now you can use it. You can use your triple integration now. So you have the triple integration is equal to 0 to pi, which is phi comes first, and then 0 to 2 pi, which is theta, and then rho 0 to 1, and then here. So remember the volume. The volume, you have to write down this one first. Let me show you here, this one, the volume. Write down this one first. Write down rho square and sine theta first, okay? The rest you can do it later on. So what's the F? You see the F here? This one is nothing than rho square. So if you have a rho square parenthesis, here you have rho, this one here. Here you will have E rho square, you got it? And then parenthesis here, 3/2. So the 2 will cancel out. So you will have E rho to the third. Do you understand here? Be careful. So then for here is just E row to the third. And I explain to you this one right now. And here, make sure you put rho square and sine theta. And I already also explained to you this one by using here, by using this one. Okay? I use this one. Okay? You have to use this one. And then also you have to use this one. Same thing. And then for you can just use the rho because rho comes first. D rho. It doesn't matter. The order doesn't matter because both are the numbers. And d theta and d phi. And that's it. And now it's easy to calculate it. Okay? That's the way. The harder part is just this one. Good. Let me know if you have any question. And good luck for your final exam. Now you should be ready to do it.